Hello everyone. Welcome to our in-depth exploration of the topic, what happens when direct current, DC, is applied to an isolation transformer. Isolation transformers play a crucial role in electrical systems by providing electrical isolation and safeguarding sensitive devices. In this video, we will dive into the effects of applying DC to an isolation transformer, unraveling the intricacies of this intriguing scenario. To better comprehend the ramifications of applying DC to an isolation transformer, let's start with a brief overview of what an isolation transformer actually is. An isolation transformer is a specialized type of transformer designed to provide electrical isolation between its primary and secondary windings. Unlike regular transformers, isolation transformers lack a direct electrical connection between the primary and secondary sides, which effectively isolates equipment and minimizes electrical noise and interference. Before we delve into the consequences of applying DC, it is essential to grasp the fundamental workings of an isolation transformer. When an alternating current, AC, is supplied to the primary winding of an isolation transformer, it generates a fluctuating magnetic field that, in turn, induces a voltage in the secondary winding. This AC voltage becomes available for powering a variety of devices and systems. While isolation transformers are primarily designed to handle AC, applying DC to them can have several notable effects and implications. Due to the absence of rapid changes in polarity found in AC, the isolation transformer fails to induce a voltage in its secondary winding when DC is applied to the primary side. Consequently, the output side of the transformer will not exhibit any voltage or power when DC is supplied. Isolation transformers are optimized for AC operation, and their magnetic cores are specifically designed to accommodate the characteristics of alternating current. When DC is introduced, the magnetic field within the transformer's core becomes constant and ceases to change direction. This can lead to core saturation, a phenomenon where the core material reaches its magnetic limits, resulting in increased magnetizing current and potential overheating of the transformer. The presence of DC in an isolation transformer can give rise to heightened heat generation, primarily due to core saturation. As the magnetic core reaches saturation and operates outside its intended parameters, excessive heat is produced. This increased heat poses a risk of damaging the insulation materials and other components of the transformer, potentially leading to its failure. Applying DC to an isolation transformer undermines its intended purpose, resulting in a loss of isolation and safety features. Isolation transformers are meticulously designed to provide electrical isolation, shielding both devices and individuals from hazardous voltages. However, when DC is supplied, the lack of isolation compromises safety, exposing equipment and individuals to the full voltage present in the system, thereby creating significant safety risks. In conclusion, it is of utmost importance to avoid applying DC to an isolation transformer, considering the multitude of adverse effects it can induce. These include the absence of voltage induction, core saturation, increased heat generation, and the loss of isolation and safety features. It is critical to utilize isolation transformers as intended, exclusively with AC inputs, to ensure optimal functionality and guarantee the safety of electrical systems. Thank you for joining us on this deep dive into the effects of applying DC to an isolation transformer. We hope you found this extended analysis valuable and informative. If you enjoyed this video, be sure to give it a thumbs up and consider subscribing to our channel for more captivating content on electrical systems and related subjects. We genuinely appreciate your support and engagement. If you have any questions, comments, or suggestions for future videos, please leave them in the comment section below. We love hearing from our viewers and are dedicated to bringing you content that is relevant and interesting. Stay tuned for our next video, where we will continue to explore intriguing aspects of electrical engineering. Thank you once again for watching, and we'll see you soon with more electrifying knowledge.